Find a quadratic polynomial, the sum and the product of whose zeros is root 2 and minus 3 by 2 respectively. Also find its zeros. So what is that we have been given? Here you have to be careful regarding what is given. Many people take these two values to be your alpha and beta. What is the actual question? The sum and the product of the zeros. Sum is this and product is this. So this is root 2 and this is minus 3 by 2. Here we have alpha and beta are your zeros. Here alpha comma beta are the zeros. So you have to be very clear with what is given. Many people end up taking alpha as root 2 and beta as minus 3 by 2. Right? That is not the case. So what is that we are going to use over here? Right? Equations from zeros. So in this case it's a quadratic polynomial and that would be your expression. So we have, let me start with the working. So P of x is equal to k times of x square minus alpha plus beta x plus alpha beta, right? So you can remember negative comes in place wherein you have alpha plus beta is minus b by a. Here you have minus and here also you have minus, right? That's how you can kind of remember it. Actually, technically you can understand it, it's not a big deal, but people who find this difficult, this is what you have to do. Okay. Next, moving on, we have k times of x square minus of alpha plus beta is root 2x and alpha into beta is minus 3 by 2. So that would be your expression. That's it. We also have to find the zeros. So what to do? See, k is any real number. So for k is equal to, what should I take? 2, right? If I take 2, this entire expression becomes what? Without a denominator, it has a denominator that is 1. So that 2 goes away basically. This 2 goes away by taking k as 2. So for k as 2, what will you end up with? 2 times of x square minus root 2x minus 3 by 2. So this would be 2x square minus 2 root 2x minus 3 divided by 2 into 2 is 3, right? All that math you guys have to do it fast. Okay, and now we can split the middle term. So quite simple. We need to multiply and add two set of numbers, which leads to 2 into minus 3, that is minus 6. Sorry, here minus 6 when multiplied, and when added it is minus 2 root 2. Since we have root 2 right in the middle term, so we end up with root 2 in both the places. So this can be written as minus 3 into root 2 into root 2. Agree? So basically we can concentrate on root 3 and minus 3 and minus 2. So when we multiply, we should get minus 3. When added, we should get minus 2. Means what? One has to be negative, other has to be positive. The bigger number is negative because when added, we should get negative. Okay, again, please understand the sequence of thinking. Pause and think over. Just don't try to understand from someone telling. Think, then rewind and watch me explaining. Okay, I hope you guys are doing that exercise. If not, whatever you are watching, it's futile. It is of no use to you guys. No, you're just watching something, doesn't make sense. Learn to think. So 2x square minus 3 root of 2x plus 1 root of 2x minus 3. And we have this and this set of terms. So what is common? X is common. 2 can be written as root 2. So we have root 2 also as common. So root 2 into x. We left out with root 2x in the first term. In the second term we have 3. Okay, that's how you have to figure it out. Here we can see we have only 1 as common, plus 1. So root 2x minus 3. And now we have root 2x minus 3 into root 2x plus 1. Right? So those are your factors, and on to finding the zeros. So let's begin with root 2 into x minus 3, which is equal to 0. So x is equal to 3 by root 2. We need to rationalize this. So I'll multiply and divide with root 2. So this is 3 root 2 by 2. Okay, and the the second expression, last also actually, root 2x plus 1 is equal to 0. So x is equal to minus of 1 by root 2. Again, we need to rationalize this. We have root 2 by root 2. So we end up with minus root 2 by 2. So this one of them would be your alpha, and other would be your beta. Okay, there's no verification now. No, that's it. Right, guys? So always rationalize. This is one thing which people miss again. They end up just writing this, wherein the denominator has a irrational number that is not acceptable in your board corrections and all of that. So we have to see to that. You have to see to that. We don't end up with root in the denominator. Any kind of root, you have to rationalize it. Okay, guys? Okay, so from here, the star would go to this point, I guess. So this is where you have to understand. And everything else is okay. And yeah, this also is a star. Take k value, which makes sense. If things are normal, just take k value to be 1. Okay. And by the way, if you take k value to be any other value, you can take 4, 6, 7, right? Any value, 100, 120, 135, whatever value you take, you end up with the same zeros. If you want, you can try. People who are curious, you can try that. You end up with the same zeros. Okay. So this is your answer.